Okay, so this is the Chapter 14 test review. And here, the first three questions are all about graphing the sine, cosine, and tangent curve. So as we go through this process, a couple things we need to remember. With sine and cosine, these two guys, the period is going to equal 2 pi over b, and the amplitude is the absolute value of a. Now, where are a and b in the problem? We're going to identify those as we go. So if we take a look here at question number 1, b is the multiplier of x. So in this case, b is going to be 2 because it's a cosine of 2x. So my period is going to be 2 pi over 2, which is equivalent to pi, because the 2's cancel. 2 divided by 2 is 1. That tells me that if I go out 4 marks to the right, that fourth mark should be labeled pi, and 4 marks to the left should be labeled negative pi. Now I ask that you label the right-hand side completely. To do that, okay, let me zoom in here just a little bit. To do that, we're going to need to split that pi in half for the middle mark. So if the fourth mark is pi, the second mark should be pi divided by 2. And if the second mark is pi divided by 2, the first mark should be half of that, which would be pi over 4. So we cut it in half again, and then if we times that first mark by 3, it should produce this third mark. 3 times pi over 4 should be 3 pi over 4. The next thing I look for is the amplitude, which is the height of the wave. The amplitude is always the absolute value of the number out here in front of cosine. Since it just says negative, I can assume it's a negative 1, and the absolute value of that is 1, which means I'm going to come up to a height of 1 and go down to a height of negative 1. The setup that we've done so far is the same for sine and cosine. Both graphs have the same structure set up, but they have a different pattern instead of where the dots go. If you can remember, the cosine graph, okay, typically looks like this, and a sine graph typically looks like this. Then you can use that pattern to help you figure out where the dots go in this specific case. Normally, cosine starts up at its high amplitude, but because of the negative in front of the equation, it's telling me that this is going to be upside down. So instead of starting at the high point, it's going to start at its lowest point. Come up through the center to its highest point, down, and it always ends right where it began. So you kind of get this kind of a shape to this cosine curve. I ask that you repeat it at least once. That's why I give you the left side and right side. So these dots should work their way in backwards fashion, producing, in this case, kind of an M shape, okay, with arrows on each side. That's our cosine graph. The next thing that we want to work on is our sine graph, which has much the same rules. Okay. All right. So with sine graph, we're still going to go and find the amplitude and the period, and our period here will be 2 pi divided by, in this case, pi. Well, here the pi's cancel, and we're left with 2. That means I can go out 1, 2, oh, that was too close. 1, 2, 3, 4, and label the fourth mark 2. Half of 2 is 1. Half of 1 is 1/2. And that 1/2 times 3 is 3/2. We do the same thing to the left and label negative 2. The amplitude is the absolute value of the number in front of sine. In this case, that's 3. You can label 3 individual marks, or you could just go up 1 mark and label it 3, down 1 mark, label it negative 3. And you should consider putting models of these on your unit circle with any information that you need to make it easier to keep track of all the details. Because this is a positive sine function, it's going to have the normal shape, which we already kind of talked about way over here. It'll start at the center and move up first, then back to the center, down to its low point, and back to center, creating that standard sine wave. If we mimic that backwards, it would be down first, up, high, return. It should look like the exact same curve repeated. Okay? Again, arrows on each end, and there's my sine wave. Tangent does have some different rules. For instance, it doesn't have an amplitude, and its period formula is different. It is pi over b. Not 2 pi, but pi. And then there's also this funky thing in here. You might have it in a tangent, it might be in a sine, it might be in a cosine. But you need to be prepared to deal with a fractional value for b. When I see something like x over 2 or x over 4, I have to think of it as a fraction times x. X over 2 is the same as 1/2 times x, so the period here would be pi over 1/2. And when I keep switch flip, it becomes pi times 2 over 1, which is 2 pi. Again, that's not a tangent-specific problem. That could happen on sine or cosine. Anytime the x is divided by a number, you need to write the b value as a fraction. So I'm going to go out 4 marks, label it 2 pi each direction. And with tangent, I require you to label the middle mark, but I don't require the rest of them. If 2 pi is the 4th mark, the 2nd mark should be pi and negative pi. The reason I like those to be labeled is because those are where the asymptote goes. There's a dotted line that breaks the tangent curve up, and I like to draw that in. The tangent curve always crosses right through in the center. If it's positive, it goes up on the right. If it's negative, it goes down on the right. And that should be enough to tell me to create this curve here and here. There is our standard tangent curve. But I require you to duplicate it at least once. So what I recommend doing is going 4 marks in every direction from asymptote to asymptote. So if I have an asymptote right here at pi, 1, 2, 3, 4. Same thing with the negative 2 pi, 3, 4. If I create those extra asymptotes, I personally think it's pretty straightforward to clean up and create the rest of the curves. Some students don't like to do that, that's fine, but I need at least 2 complete cycles, and I really like the symmetry of having it show up 3 times. Okay. Okay, so these next 3 problems, if you don't have all of the equations and identities, I called it the toolbox. If you don't have the toolbox of identities written down, you're not going to be able to just, it's that or memorized. If you don't have access to the information, you're not going to be able to do them on the test. So while some of this is going to seem like, well, how did Mr. Welch remember that? Well, I've memorized it, but if you don't have it memorized, you need to have them written down on your circle. So for instance, when I look at this cotangent over cosine, I don't see anything that's Pythagorean. There's no squared values. So all I'm going to do is try to change everybody to sines and cosines. One of our definitions on our sheet should say that cotangent is equal to cosine over sine. And this whole thing is over cosine. Let me zoom in here a little bit. That's pretty small. Okay. Well, now I have a fraction in a fraction. If I want to fix the fraction problem, I'm going to do a keep switch flip. So this problem becomes cosine over sine times 1 over cosine. All right. Well, a cosine over a cosine should cancel, and that leaves me with 1 over the sine of x. We prefer not to use fractions, So 1 over sine could be written, based on my identities, as the cosecant of x. Anytime you have a stacked fraction of trig functions, you should expect to turn things into sines and cosines and do a keep switch flip. And then it's just about simplifying and seeing what's left. All right, let's take a look at question number 5. Again, our focus, if we don't see addition or subtraction with squared values, is to just go to our favorite two kids, which are sine and cosine. Tangent is defined as sine over cosine. This is times sine, which I'll go ahead and put over 1, and times secant, which is 1 over cosine. Again, if you don't know why I know that, look in your toolbox. We're just trying to turn everybody into our two favorite kids, sine and cosine. I look for things that cancel, but this sine is not going to cancel the sine over here because they're not top to bottom. So that means I'm going to multiply straight through. Sine times 1 is sine squared over cosine times 1 times cosine is cosine squared. Oops, that wasn't very good. Well, sine squared over cosine squared doesn't cancel anything, but I also know from my earlier problem that sine over cosine is tangent. Therefore, all of this becomes tangent squared of x. We got to a single term. Yeah, it's squared, but it's at least just one object. All right. About halfway done. Number 6, I see the squared values, I see addition, so it's telling me there's something Pythagorean going on here. However, when I look at my Pythagorean identities, I see things like sine squared plus cosine squared equals 1. I can see the plus cosine squared here, but where's the sine squared? I don't have it. But if I try to fix the multiplication over here, tangent squared times cosine squared, if I can condense that and bring it down by using sines and cosines, my tangent squared would be sine squared over cosine squared times cosine squared over 1. And don't forget, we still have our plus cosine squared that we haven't touched. So kind of keep track of these two different things. We're doing the multiplication condensing, but I still got that cosine squared sitting on the side that I'm not touching. But here in this middle box, or this left side, the cosine squared will cancel this cosine squared. It only works because it's a multiplication problem. You don't get to cancel addition. But because it's a multiplication problem, this left side is going to simplify now to sine squared of x plus we have our cosine squared of x, and based on our Pythagorean identity right up here, this whole thing equals 1. Okay? So is it going to equal 1 every time? No. It could be tangent squared, it could be sine squared, could be a lot of different things. But for us, specifically because we simplify to sine squared, cosine squared equals 1. Now, is there an easy, like, always do this approach, it's going to be easy on the test? The answer is no. The more you've done these identity problems, the easier it is to see the steps coming ahead. If you didn't do the 14-3 homework at all, I don't really have a good suggestion. You're kind of in a bad place. I wish I could just take it away and make it easy, but that's not how it works. Okay, the rest of the problems are a little bit more just algebraically focused, so good news, we've got some pretty straightforward stuff to do here. We will need our unit circle to answer 7 and 8. Notice it says to solve the equations for 0 to 2 pi. That means that when we're done, we don't have to add the plus 2 pi n. It's just the numbers that are coming from the circle. But we do have to solve for our trig function. So I want to get the cosine of x alone. I'm going to do it by peeling layers. Let's just add 3 to both sides. 6 cosine now equals 3. If I divide by 6, the cosine of x now equals Let's call it 1/2. The second that your trig function is alone, that is when you go to your unit circle. Okay, so the cosine, it is the x-coordinate, and you should have the x-coordinate at 1/2 at, where did we hear? Pi over 3. Look at your unit circle, that's 60 degrees. But at pi over 3, the x-coordinate is 1/2. There should be a second answer. 5 pi over 3. Cosine moves straight up and down. 5 pi over 3. If any of that doesn't make sense to you, come talk to me in class. That is just reading the unit circle for your answers. Notice, I want them between 0 and 2 pi. I don't want the degree equivalent. But if you wrote the degrees down and the radians, you're not getting it wrong. I want you to tell me the radian version. Question number 8 is similar, but has a little hiccup that you've got to pay attention to. All right. We're going to start by adding 2. If you're not sure what you should do first, just remember that it's SADMEP. We do addition, subtraction, then multiplication, division, then exponents and parentheses. Next, I'm going to divide by 2. Squaring this, or square rooting, will be the last thing I do on this problem. I want to get everything else out of the way first. My problem now says that the tangent squared of x equals 1. Well, how do you get rid of a square? Take a square root. That would lead me to say that the tangent of x is equal to, well, what's the square root of 1? 1. But because we created the square root, we have to cover for the fact that it could be positive or negative. So it would be positive or negative 1. And we have to accept all answers associated with that. Now, if you do not have the tangents of 30, 45, and 60 written on your circle, you need to get them written down. But on our circle, what is one of the places where the tangent could equal 1? Pi over 4. Now, if I want its positive equivalent, we follow the diagonal, which would put me at 5 pi over 4, right? But because I'm also allowed the negative of 1, then the opposite diagonal should work as well, which would be 3 pi over 4 and 7 pi over 4. Those are all necessary and acceptable answers to the problem. All right, 9, 10, and your bonus question are about the formulas for sum and difference formulas. And you can, on some of these, like on number 9 and 10 in this case, you could use the half-angle identities, half-angle formulas that we learned last time in 14.7. But you could do 9 and 10 with a sum and difference, which typically feel a little easier to do because you don't have to worry about square roots and plus or minuses. A little simpler. But you do have to have those formulas written down. First thing that we have to do is convert the 15 into either an addition or a subtraction of two things. Because 15 is smaller than my smallest angle on the circle, which is 30 degrees, I'm thinking subtraction. Can you guys come up with a subtraction that would get me 15? 60 minus 45? That's fine. So there's my A and there's my B. Now hopefully you wrote down these formulas on your circle, but if you don't have them written down, does anybody remember the formula for sine of A minus B? Sine of A, oh my goodness, Mr. Welch. Sine of A times cosine of B. Is the sign supposed to match or be different? It matches with the sine rule. Then it's cosine of A sine of B. That is not something that I necessarily expect you to memorize, but it should be written down on that unit circle. There's a reason I give you a circle for the trig forward on the finals. on the test. It's because there's a lot to remember. This now becomes about reading the unit circle. There are 4 answers that I need to pull from my circle. What is the sine at 60 degrees? It should be root 3 over 2. If I'm reading that wrong, you let me know. Times, what is the cosine at 45 degrees? Root 2 over 2. Minus the cosine at 60 degrees, which is 1/2, times the sine of 45, which is root 2 over 2. I know that everybody's going to have a denominator of 4. These answers are all the same. Root 3 times root 2 is root 6, minus 1 times root 2 is root 2. And there's my answer. If I went too fast on the simplification, go back to 14.6. Remember how to do that? Or come and ask me that question. Remember, this 2 times 2 here is 4. This 2 times 2 here is 4. So we end up with all of it over 4. Tangent, same idea, but the rule is a little different with tangent. I want to turn the 105 into something. Let's go ahead and do an addition version. How about 45 plus 60? 60 was the one we preferred to use, right? We prefer to get away from the 30-degree angles because of what the tangent is. Okay, so we have an A and we have a B. Starts with the tangent of A. Keep the same sign, tangent of B, all over 1. And it's the opposite sign, right? Tangent of A times the tangent of B. That's our formula. Now, you don't have to have that memorized, but you might need to do an example problem on your unit circle just to get through, like, what does the tangent formula look like? Now, we're only doing 2 of these, so it's possible that you get a sine and a tangent, or a sine and a cosine, or a cosine and a tangent. You just have to be able to do all of them, so you be able to manage all of them. What is the tangent of 45 degrees? 1. Plus the tangent of 60 should be the square root of 3. Focused on the 6. All right. Over 1. Remember, this is tangent of 45 is 1. Tangent of 60 is root 3. If I multiply those together, it should be minus root 3. If you give me this answer, you're going to get most of the points right now. The last step is really just, do you understand the cleanup process and can you go through it correctly? We multiply the top and bottom by the conjugate of the bottom. The bottom says 1 minus root 3, so I multiply by 1 plus root 3. The fact that that matches the top is purely a coincidence. It is not because there's some special secret. The focus is definitely on being the opposite of the bottom. On top, 1 times 1 is 1. 1 times root 3 is root 3. Then we go root 3 times 1 is root 3. And root 3 times root 3 is root 9, which we know is really 3. I'm going to go ahead and clean up the top. 1 plus 3 is 4, and root 3 plus root 3 is 2 root 3. Again, I know I'm going through this fairly quickly, but that's what pausing the video is for. On the bottom, 1 times 1 is 1. 1 times root 3 is a positive root 3. But a negative root 3 times 1 is a negative root 3. And a negative root 3 times root 3 is a negative root 9, which we know is really a 3. Well, here in the middle, the root 3 minus root 3 cancel. and we have 1 minus 3 or negative 2. The last step to these problems with tangent is always to simplify the big 3. We reduce them all. I don't like having a negative floating around in the denominator, so I'm going to divide everybody in the big 3 by negative 2. 4 divided by negative 2 becomes negative 2. 2 divided by negative 2 becomes negative 1 with a root 3, and the bottom is canceled. Okay. The last thing we have is the bonus problem, which is the cosine of 22.5. This is a half angle identity, which makes it the cosine of 45 over 2. 45 is the a value. Now the cosine formula for a half angle is plus or minus the square root of 1 plus, is it plus or minus? It is plus cosine of 45 all over 2. And if we try to simplify that, it's plus or minus the square root of 1 plus root 2 over 2 all over 2. Go through this pretty quick here. If you did the homework assignment, you know that I always came in and made my 1 into a 2 over 2, which allows me to get 2 plus root 2 all over 2 all over 2 in that square root. This 2 is going to make that 2 become a 4. So we end up with 2 plus root 2 all over 4. But we know the square root of 4, so it ends up looking like 2 plus root 2 all over just regular 2, because the square root of 4 is 2. And the only thing we have left to figure out is whether or not it's positive or negative. That goes back to knowing the cosine of 22.5 degrees is the x value of an angle that lives over here. Right? This would be about 22 degrees. The x value over here is positive on a unit circle, so it tells me that the answer is a positive square root of 2 plus root 2 all over 2. Whoops. That's our final answer. Good luck, guys. We'll see you in class.